Good morning, 4th and 5th graders. My name is Mrs. B, and we're going to talk about science. Today, let's start with a quick review of our 5 senses because we always need them ready to pay attention and make our observations. So, quick review, we're going to maybe use our sense of touch, hearing, smell, taste, and our sense of sight. So let's start with some examples here. And I want you to think about, when I give you each of these examples, whether new matter is forming or being made. So remember, matter is anything that takes up space and has mass. I have matter, you have matter, everything you see here with me is made up of matter. And so if we are building with blocks, do you think that we are creating a new substance or making new matter? And here's a physical example that I have. So I drew this here, but if I am building with blocks, am I making new matter? What about, am I making something new when I'm baking a cake? If you ever baked before, you've seen someone bake, what happens before you bake a cake? What happens during? What happens after? What about when you're making a sandwich? Are you making something new, a new substance? When you're making a sandwich, maybe this is supposed to be like a submarine sandwich with bread, maybe some meat or peanut butter and jelly, some cheese. What about when we're frying an egg? So substance is a type of matter that has a specific property. And properties are the way we can describe or identify matter. And so our substances can have physical properties. And those are things that we can easily observe. We can observe their color, their shape, and their texture. Or we can also observe their chemical properties. And these might not be so easily observed. We might need to do some investigations or some tests to check their chemical properties. And some examples of chemical properties would be if a substance, if matter burns, or it rusts. So think about before we build with blocks or bake a cake or make a sandwich or fry an egg. What are all the substances, the parts that we're putting together, and then what's happening when we're putting those things together? What happens at the end? Are we making new substances? And that's what we're going to investigate today. And so I want us to start with 2 investigations. The first investigation is a story I'm going to tell you about what I did with some table salt and water that you could try at home. So before I put table salt in water, I made some observations. So before my investigation, what did I observe? I observed that salt, table salt, is white. It's granular, little grains, they look like cubes. And that the water was clear. Then I added my table salt to the water and I stirred it and dissolved it. And after 3 days, I observed less water. What do you think was happening to the water? So the days have been getting warmer. My water started to evaporate. And after 7 days, I had no water, but I did have white grains, or I had the table salt again. So after a week, after 7 days, what do you think happened to all of the water? It completely evaporated. When I combined my table salt with my water, did I make a new substance? I have a second investigation. This time, and maybe you've already tried this or you've seen this before, we're going to combine baking soda and vinegar. And I want to show you two ways that you can make observations. The first one is in a plastic bag so we can see what's happening. And the second one is I'm going to use a bottle. We might not be able to see everything that's happening. So I'm going to put some baking soda in one corner of my plastic bag. Make sure I have a good amount here. And I could smell my baking soda. It does have a scent. Doesn't smell very good. How would I describe that? It's a little sour smelling to me. And I could taste it. It's also a little bitter. And then I have some vinegar in this bottle. Vinegar is clear. It smells very sour. So I'm going to pour some vinegar into the other side of my bag here. Not too much. I need to save some for the other way we're going to show this. And I'm going to completely seal my bag. Try to get as much of the air out as possible. Leave that sealed tight. And then I'll combine my baking soda and vinegar. And if you've seen this before, you know what to expect. I can hear fizzing. I can see now that the liquid is not completely clear. I can see that my bag is filling with the gas. And now I have a white liquid, and I also feel that the bag is very cold. Where the liquid is, it's very cold. So for my second investigation, before I had a white powder, I had a clear liquid. And I could use more of my senses to describe their smell, their taste. I know that baking soda and vinegar is safe to taste. And then during the investigation, I heard fizzing. I saw the bag fill with gas. And after my investigation, when I saw all of my baking soda mixed with the vinegar, I saw a white liquid and the bag was filled with gas. And what else? And I saw bubbles. I still see some bubbles. And the bag was cold to the touch, or where the liquid was cold to the touch. So I want to show this to you again, but this time with a balloon. I already have vinegar in my bottle, and I'm going to put some baking soda inside of my balloon. I forgot my funnel, but if you have a funnel, you could also do it that way. Do it over the bag. So I have some baking soda inside of my balloon, and I have some vinegar inside of my bottle. Again, before my investigation, I have white powder, I have a clear liquid. We can't see it through the blue bottle, but I assure you it is vinegar. And then we should expect the same observations. So I'm going to let all of my baking soda So again, this time, instead of a bag, I saw my balloon fill up. I heard fizzing. I hear fizzing. Can you hear it? And then, Again, if I look inside, I should expect to see a white liquid. The bottle feels cold again. I felt a change in temperature. So when did I make a new substance? And so how do we know when we've made a new substance when we're mixing matter? So some things to think about. Both a mixture and a new substance, we need two or more substances when we're mixing our matter. However, a mixture is something that we can separate. And a new substance is when we can't separate the parts that made or the parts that were combined to make the substance. So for example, with our building blocks, I can separate each of my building blocks and make something else. So some evidence that's going to help us determine whether we made a new substance is a change in temperature. When I'm building with blocks, I don't have a change in temperature, I don't see gas bubbles, and I can get the original substance, the blocks. When I am baking a cake, whether you get it out of a box from a mix, it looks like a white powder, or maybe you put some ingredients together, you have eggs and flour, water, milk, baking soda, baking powder. When we're taking all of those together, combining that matter, there is going to be a change in temperature when we bake it and put it in the oven. Sometimes, if you've ever observed a cake baking, or cupcakes, or bread, what's evidence that there are gas bubbles being released? Sometimes it inflates, and when we pull it out, it deflates. So something was happening there with gas. And then can I get my egg, my flour, my water, my milk back? I can't. I've made a new substance when I bake a cake. How about making a sandwich? Now, this depends. I'm going to say it's a cold sandwich. We're not changing its temperature. We don't observe gas bubbles when we're making a cold sandwich. And we can pull apart the different things. It might be a little messy with a peanut butter and jelly sandwich, but we could get the jelly and the peanut butter back. When we're frying an egg, can we get the egg back inside of its shell? No, so we can't get the original substance. If you've observed an egg frying, do you sometimes observe bubbles? Is there a change in temperature? Yes, there is a change in temperature. So based on the examples and what we've learned so far about mixtures, creating new substances, combining matter, what questions do you have? So let's take a moment to go through some questions that are coming to your mind. What's a question that starts with what for you? How about what if? How? When? Why? So a way to show your learning around combining matter, making new substances, or mixtures, we can draw a model, and remember with our model, use key vocabulary like mixture, matter, substances, temperature, physical and chemical properties. We can draw lots of pictures, and we can write an explanation. And here are some examples of symbols we can use. It's really important to use as many pictures, symbols, and words as we can to share our thinking and our ideas around what we're learning. So we can show maybe some direction, or if the temperature is increasing or decreasing, maybe if we're starting to see some steam. How would you draw bubbles, gas bubbles? Another thing I would encourage you to show your learning and explore mixing matter is to come up with your own investigation. So here was my investigation. What are 2 or more things that you would want to combine? And then what are you observing before? Remember, use all of your senses, especially if you're going to do something in the kitchen. We need as many of our senses on because there's a lot happening with changes in temperature, with the tools we might use that could be sharp. So what are you observing before your investigation? What are you observing during your investigation? And then after? And then be sure to find evidence to support whatever conclusion you're making about whether you did or did not create a new substance. We want to see a change in temperature, we want to see some gas bubbles, and maybe we can't get the original substances back to their form before they were mixed with other matter. So I'm so glad you joined me today. Until next time, I hope you have a great day.
Hello, mathematicians, and welcome to At Home with APS. I am Miss Obenshane, and today we're going to do an activity to start out that we're going to practice some skip counting with. Skip counting can help you keep track of groups when you're thinking about multiplication, and so it's a good thing to practice skip counting forward and backward with different sequences. The activity we're going to do is called Disappearing Sequences, and it comes from a book called Developing Number Knowledge by Robert Wright. If you're going to do this at home, you can write down whatever sequence you want to work with. We're going to work with 6s today. Or you can use cards, and I'll show you how you could use cards, and the video link that you'll have access to off of our website shows the kids using cards. But either way, it's the same game. So you start out by just writing the sequence of numbers you want to practice. And so we're going to practice 6s because 6s are kind of a hard counting sequence. And Ms. Gaudet is going to help us with our practice today. You can do this by yourself. You don't have to have a partner, but sometimes it's fun to do this activity with a partner. So let's say our skip counting sequence a couple of times so that we are fluent with it. We feel like we're just not having to hesitate too much. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Let's try it one more time just to make sure we're nice and smooth. 6, 12, 18, 24, 30. 30. Good thing Ms. Gaudet is here. 36, 42, 48, 54, 60. Okay, and so how this game or activity, it's really an activity, not a game, goes, the sequence is going to disappear because we're going to cross off numbers, but we're still going to say the whole sequence, and the crossed off part will just kind of remind us what was there in the sequence.
So it's like a placeholder.
So it's like a placeholder, yeah. So you can just kind of get a visual picture of what these numbers look like in your mind, and then we're going to scribble them out, and you have that marker to kind of hold. You can try to visualize what was there. So I'm going to ask Ms. Gaudet to pick one that she wants to cross off of our list.
Well,
She's going to
since
scribble
Ms.
it out.
Obenshane messed up on this one.
Oh, no.
Oh, they can still sort of see it. Oh, well. Should I get a different color?
Maybe we should cross out with black, huh?
All right, I'm going to have to get black.
Yeah, black will have to work. Because you do want the number to be kind of crossed out so whoever you're playing with or working with can't really see it there anymore. Okay, so now we're going to say the sequence again, and we will still say what was there, but we just have to remember what was there. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Oh, okay, now I get to mark one off. I think that I'm going to go with this one right here. Okay.
Man, you really scribbled that.
That's the funnest part. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. All right.
I can already tell that this is going to be fun, but it's going to start getting a lot harder very fast. All right.
See, isn't that fun?
It is, actually. It's really satisfying.
Okay, here we go. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Okay, I'm going to do this one. Hopefully you can't see it. Okay. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60.
You notice I'm always trying to go for the easy ones first. What I think are the easy ones.
Yeah, I don't know. Sometimes that backfires.
Yes. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. I know I'm gonna mess up now.
Okay, here we go.
6, 12, 18, 24, 30, 36, 42, 48, 54,
60. We're doing pretty good. All right. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Ooh. Let's get rid of this whole row right here now.
Ooh, eek.
All right.
6, 12, 18, 24, 30, 36, 42, 48, 54, 60.
Almost there.
That's not working anymore.
Yeah, mine's getting kind of. Okay. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. All right. Last one.
We can do it. We can do it.
See if we can get them all. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Now you can really challenge yourself by trying to go backwards. And going backwards with skip counting is important also because it will help you with division. So let's try to go backwards, Miss Gaudette.
Okay, I could do this.
60, 54, 48, 42, 36, 30, 24, 18, 12, 6.
Thank you so much for going slower.
All right, so that's how you play disappearing sequences. I told you that I would just show you, you can play it on a paper like this, or you can make cards if you want to play it over and over and you don't want to have to use paper. And with this, you just put the same sequence out. And these cards just say that same sequence that we just had up there. And you would do the same thing, and your partner would just flip a card over, or you can flip a card over. And you say the sequence, and then you flip another one, and you say the sequence and flip another one until all your cards are face down. So that's just another variation. If you watch the video on our website, or that's linked to our website, what you'll see is kids playing it with cards. So just wanted to explain that variation. All right, thank you, mathematicians. And now Miss Gaudette is going to do some problem solving with you.
All right, you guys ready? I sure am. Reminder, we have all of these problems up on our website. Go ahead and download them so that you can work through them first before you have me show you how my thinking on the answer, or have a sheet of paper out, a pencil out, and pause after every question. So you can just remember, see what I call teacher talk. I'm showing you how I process through those problems. So you're seeing another way besides your own. All right, so let's get started. Let's review what we did last time. We were working on fractions and thinking about how to place those fractions on the number line. So our first question said, mark the position of the two fractions, 2/3 and 2/5 on the number line. We have our 2/5, we have our 2/3. Do you remember how we placed those? I always did it by the denominator. That helps me out on how many pieces that I need to do. So that was the first one. The second one, explain how you decided. Over here, it says, take the denominator to decide the number of spaces. That's how many spots on the number line. That's kind of my thinking through it. Mark that amount on the number line, 3 and 5 spaces. 3 for the 2/3, 5 for the 2/5. I found where 2/3 was and where 2/5, meaning I counted off by the 2. count of 2 spots, 1, 2 to get the 2/5, or 1, 2 to get the 2/3. So sometimes my writing doesn't quite say everything I'm thinking, but that's something I could work on. So you see that even teachers have things they could work on. My explanation needs a tad bit of work. All right, so number 3 said, which of the 2 fractions, 2/3 or 2/5, is nearer to 1/2, and explain. This is where we left off last time. We had 2/5 was nearest to 1/2, and my explanation said 2/5 when I found an equivalent fraction with the same denominator, 10, I found 4/10 and 5/10. And I said, that proved it, right? I had forgotten about the 2/3. I can't believe I did that. So let's go ahead and let's really fast work through that so that we can see if it's true or not, if what our prediction was true or false. All right, so we know we have a denominator of 5, 2, and now 3. So 10 will not work as my common denominator. Why? Right? 3 can't go into 10 evenly, so it can't be a common denominator. So what is a common denominator of 2, 5, and 3? 15, right? 5 will go into it, but 2 won't. All right, 20, nope, that won't work. 30, 5 will go into 30. 3 will go into 30. Yes, I'm gonna use 30. I get excited. If you guys don't know me, I love some math. All right, so we have to look at what can we do to 5 to get to 30? What can we multiply 5 by to get 30? 6, thank you. So again, whatever we do the bottom of a fraction, we have to do the top to keep it equivalent, equal. So 5 times 6 is 30, so 2 times 6 is 12. And remember, these might be confusing you a little bit. So if you needed to erase it, or as I actually like to cross out the work that is not helping me anymore, so I can still see my thinking and my thought process through that. All right, so what did we do to 2? What did we multiply 2 by to get 30? Thank you. 15. So whatever we do the bottom, we do to the top to keep it equivalent. And 1 times 15, right? 15. Now what can we do to 3 to get to 30? Multiply it by 10. And again, let's do it on the top. So 2 times 10 is 20. All right, let me see this. All right, I know my numerator is 12 and 15, so I have a difference of 3 here in the numerators. And then on the numerators of between 1/2 and 2/3 is 15 and 20, so that's 5. Did I prove that 2/5 is nearer to 1/2? Did I prove that? I think so. I could have also maybe had said that I saw here that 2/5 was nearest to 1/2 also. But with this, there is no real proof. That's just like my estimate, my guess right here. But if we actually did some math to prove our reasoning, we have more of that logical steps and thought process. All right. So this time, I'm gonna leave my explanation through my math. And sometimes that is okay. Sometimes we want it written out. But a lot of times when we write it out, what happens is I just write out my steps that I automatically did anyways. Sometimes that's good, and sometimes this is more than enough proof, depending on what you're needing and what the question's asking. So let's look at 4A. Mark the positions of the following numbers, 1 and 6/8, and 1 and 856 thousandths on a number line. All right. So, let me think. You notice I'm trying to think also about this. Which one do you think will be the easiest? Probably some of you were saying the fractions since we were working with fractions before. Okay. So I know I have eighths. And I know that means I have to have 8 spots. Okay. How can I make that easier? Do fourths first, right? So I'm going to do my fourths. Then from there, I can make my eighths because each fourth split in half will help me make that eighth. Okay, perfect. And then I just count off the 6 for the numerator, that I have 6 pieces out of the 8. 1, 2, 3, 4, 5, 6. So this is 1 and 6 eighth. Now I know I have 1 and 856 thousandths. Well, how could I break that up now so that it would help me? I know. I thought about it. What place value is this 8 in? It's in tenths. So if my whole was between the 1 and 2, how many spots would I have? 10. Let me change color for that so you can see my different thinking here. So I need 10 now. All right, so I know this halfway is 5. So I have to get 5 spots in between here. So 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. And you notice I had to double check myself. I don't always trust what I'm doing, and so I have to double check. 1, 2, 3, 4. So 1, 2, 3, 4, 5. Perfect. And then I mark 1 and 856 thousandths. All right, so I know I have 1, 2, 3, 4, 5, 6, 7. Wait, did I do this wrong? Oh, I forgot to count the half. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8. But then it's not 1 and 8 tenths. It's 1 and 856 thousandths. So what we got to do next? Yeah, we need to go ahead and find that next number, that next place value, the hundredths, to help us out, which is 5. So knowing that it's 5, where would it be? Would it be about halfway between, right? So I'm going to say about this spot is 1 and 856 thousandths. Okay. So, did anybody catch me? I forgot to mark it up, right? We were supposed to find the positions of these two numbers. Then we got to explain how you decided where to place 1 and 6/8 and 1 and 856 thousandths on the number line. All right, so now we're going to move into this, our explanation. So we have 4b. And now you notice I'm just going to explain my thought process. So every place where I place, every step of how I placed it. I placed 1 and 6/8 by marking off, that's the lines between 1.5 by fourths, then by eighths. For 1 and 856 thousandths, I know that decimals are, oh no, we went out of room. All right, let me get a new paper. A value of tenths, I'm gonna abbreviate, tenths, hundredths, and thousandths. So what I would like you to go ahead and do is I'd like you to go ahead and finish writing that and then decide which of the two numbers between 1 and 6/8 and 1 and 856 thousandths is closer to 2. So I'm going to leave you with that, and Ms. Carness will be coming to talk to you about a book.
Thank you, Ms. Gaudet. Okay. Hello there. Ms. Carness here to read a book with you today. All right. Let's see here. We've got fabulous. Okay. So today's book is called If You Made a Million, and it is written by David M. Schwartz, and it's illustrated by Stephen Kellogg. He's a great kind of famous illustrator of children's books, and this is a scholastic book. So this book is all about jobs that you can do to earn different amounts of money, and thinking about those amounts of money. So we're going to be reading about that you can earn money, and also thinking about ways your money can earn money. Did you know that could happen? We're going to learn a little bit about that today. So let's get started. If you made a million. All right, so the first job is feed the fish, earn 1 penny. And she did. Congratulations, says the magician. You've earned a penny. It will buy anything that costs 1 cent. It's probably not too many things, huh? So she's gonna buy, guess what? Some pebbles. A pebble for a penny. That's something she could buy. The next job that could earn you money in this book is dust the duck, earn a nickel. And he did, dust the duck. So he earned a nickel. Well done. 1 nickel is worth the same as 5 pennies or 5 cents. The next chore that we could do to earn some money is please paint this pot purple, earn 10 cents this time. And she did. So she has earned, hooray, 1 dime. What are some ways we could make up a dime? A dime is the same as, how many nickels? 2, right? And same as 10 pennies. All equal 10 cents or 1 dime. Oh my gosh, you guys, this next job looks really big. This job is blow up this boa and you can earn 25 cents. And they blow and blow and blow, and they do. They earn a whole quarter. A quarter is the same as, how many nickels do you suppose? That's right, 5 nickels, or 2 dimes and 1 nickel, or 3 nickels and 1 dime, or even 25 pennies. All of those equal 25 cents, same as a quarter. We're into the big bucks now. We're looking at earning $1 if we can fix the flow on this fountain. We've got our plunger, and look, we found the problem. It was a frog infestation. So we fixed the fountain, and now we are $1 richer. We could get our dollar in 4 quarters, in a paper dollar, as 10 dimes. How many nickels, I wonder? Twice as many, 20 nickels or 100 pennies. So you could use your dollar to buy 100 pieces of penny candy. That's a lot of candy. Or you could buy 25-cent balloons. Or 10 stickers for 10 cents each. Or 4 rubber balls that cost 25 cents a piece. Or perhaps you'd like to save your dollar. You could put it in the bank. And a year from now, it will be worth $1.05. The bank wants to use your money, and it will pay you 5 cents to leave your dollar there for a year. The extra 5 cents is called interest. And this is one of our vocabulary words for today. Interest is money paid regularly at a particular rate for money that is saved in a bank. We're going to think a little more about interest now. So, let's talk about how that works. We're going to go ahead and use a visual model to help us think about this. So, this is going to be a model of our dollar. We've lost our interest. Not really. Okay, so this represents our whole dollar, right? So the whole thing is worth $1. Okay. And this dollar is made up of a bunch of units, 100 units. So each square inside represents a unit of 0.01, okay, which we would call 1/100th of the dollar. You might recognize it if I put a dollar sign in front of it because it's also the same as 1 cent, right? So, how many units do we have inside this dollar anyway, if they're all worth 1 cent? There was a clue in the book, wasn't there? How many 1 cents in a dollar? That's right, there's 100, right? 100 pennies in a dollar, 100 units inside this dollar. We could prove it by counting all of our squares if we wanted to. We could also prove it by thinking about 10 units across and 10 units down, and that will give us 100 as well, right? So we can think about our dollar in different ways. We can think about it as one whole. It's our whole dollar, right? We could think about it as a certain number of parts, like a fraction. It's 100 out of 100 units. We could also think about it as a percent. A percent is a special kind of fraction that's all about a number of units out of 100. So this is also 100% of our dollar. It's the whole thing, isn't it? All right. So, interest, though. Interest. So if we were going to earn interest on here, 5%, and if percents are all about a certain number out of 100, what would 5% of this dollar look like? It would be just 5 units or 5 squares, right? So we can mark that off and see what 5% of our dollar looks like on our visual model. There it is. So we could think about this as we can also think about our 5% as a fraction. It's 5 units out of 100 units. We could think about it as a percent, right? A certain number of units out of 100. It's 5%. But how much is it worth? Well, if each square is worth 1 penny, then 5% of our dollar is worth 5/100ths, or 5 cents, right? 5 cents is 5% of our dollar. And so then at the end of our year, we have not only $1, but we have our extra 5%. We have our whole dollar plus 5% more, $1.05. We can also use multiplication to figure this out, right? If you don't want to use a visual model. Gonna switch to a darker marker so we could multiply. Here's our whole amount, right? $1. And we need to multiply our dollar by 5%, or 5/100ths, which we write as a decimal, right? All right, let's multiply. So we have 5 times 0, this gives us 0. Another 5 times 0 gives us 0. 5 times 1 gives us 5. And we can multiply our 0 across just to help us keep track of our places if we want. 0 times 0, here's a 0. Another 0 times 0, 0. And 0 times 1, 0. And this just helps us to sort of keep our digits lined up. Now we need to add these together, don't we? So we have 0, 0. 5 plus 0, 0. Another 0 here. And then there's a rule about knowing how many numbers to have behind the decimal point. We have 2 4 numbers behind the decimal point in our problem. So in our answer, we also need 4 digits behind our decimal point. We come up with our same answer, 5/100ths. And it might look more familiar to you, again, as 5 cents. Did you notice that we didn't even really have to multiply this? Why not? Because really, we're multiplying our 5/100ths by just $1. Excellent. So this is how your money, if you put it in the bank, can earn money all on its own just by waiting there. When we come back next time, we'll read more of the book. We'll see how your money in the bank can continue to earn money, and we'll read more until we make $1 million. Thanks, guys.
That's just making me think about doing a whole bunch of chores now to earn some money. I'm getting excited about that. You're going to stay with me, Ms. Karnas. I'm Mrs. Sears, and I'm going to be playing a game with you today. The game that we're going to be playing is called Multiplication Salute. I wonder if you've played that game before. Salute, though. Salute sounds like something you might do in the military, right? Salute? Yes, we're going to be doing that, but we're going to be using a deck of cards. Let me explain how this works. You'll need 3 players. You'll need your player that you're playing against, and then you'll also need a dealer or a caller that's going to be naming the product of the 2 cards that you're going to see. So I have already given us cards, but normally the dealer would have passed out these cards to us as we go. In this case, we're gonna try and keep our social distancing. So I'm gonna be pulling a card, and she's gonna be pulling a card. And so what's gonna happen is, let me explain something about the cards too. Our ace can be an 11 or a 1. That's gonna depend on our caller, on our dealer, who's deciding how they wanna use that ace if it comes up. A jack, king, or a queen is gonna be worth, the face cards are gonna be worth 10. And then any other card, the 2 through 10 are gonna be worth their value that you're gonna have. So when we get ready, normally the dealer would go ahead and hand us a card, but me and Ms. Karnas are gonna choose from our own pile. We're gonna pick up a card. We'll just do a practice round here. Okay. We're gonna pick up a card. Now notice something. I'm gonna have the card here, and on my head, I can't see the card. The only time that it's gonna happen when we pick up this card, and normally we should say salute when we pick up the card, we're gonna turn to each other. Okay, so I'm turning to Miss Carnes. I can only see that she has a 5, okay? You wanna go ahead and tell me what you can see?
And Miss Sears has a 9.
Okay, so the
product
of that number would be 45. That's what your dealer or your caller is gonna say. So knowing that information, knowing that I can't see my card, I need to figure out the factor that's gonna multiply with the other factor to get the product. So I would say if the product is 45, that means my factor is a 9. And that would be available for me to be able to win that round. Okay?
All right.
All right. So we do have a caller who's a dealer that's off stage that's going to be doing it. And the other thing that we thought would kind of be kind of fun, because we don't want to really be talking over each other, but we're going to try and like either ring a bell or I have sort of a magic wand that makes a ring on it. So I'll know it's my turn and I want to try and answer it first. Typically, we're going to give you some time to think, so we're going to make sure we model that as well. All right, are you ready to begin?
Oh, I think I'm ready.
Okay, so this is called multiplication salute. So ready? Salute.
Salute.
Okay,
The product is 63.
okay. Let me do this. If the product is 63, that means my factor is a 7 because 9 times 7 is 63. All right.
Okay, she's right. She's right.
Ooh.
So she.
Well, actually,
gets the
let's just
card.
put
We'll
your
just
card
put 'em
there.
in the middle.
Yeah. So we'll keep a pile.
Okay. My bell's a little defective. Okay.
All right.
We'll try again.
You ready? Ready? Salute.
Oh, whoop, whoop, whoop.
Oh. Okay.
The product is 18.
Product is 18. Let me. Oh. I got to get my thing to go quicker.
I know my doubles, so my number must be 2. Because 2 times 9 is 18.
Oh, okay. So 9 plus 9 is also 18. Yeah, that's right.
Correct.
Okay. I'm going to put yours over here.
Thank you.
So, all right. Are we ready? Salute. Okay.
Ooh, the
Miss
product
Carnes,
is
I can't see.
The product is 60.
60. Ooh, okay. Ooh. If the product is 60, okay, she's got a face card, so that means it's a 10. So 60 divided by 10, I'm going to do it a little bit differently.
Oh.
Means my factor must be a 6.
She right?
Am I right?
She is correct.
Gets the cards this time. Okay.
Ready?
So.
Salute.
The product is 54.
Ooh.
Ooh.
Oh. I'm not sure. I'm thinking of something.
I'm right. Okay, so if the product is 54, then my number must be, I hope I'm right, 9?
It is a 9. I can see a 9. I must have a 6.
9s are hard, and
Yeah.
6s are hard too, because 6 times 9 equals 54.
I thought about that 10 that I had, that face card, and this was a strategy that Miss Openchain gave me last time. Just use that, multiply by 10, and then take away one of those other factors
I
that might
remember
be
to
involved.
use a 10 fact, that would have been a lot
Yeah,
easier to
that was
remember.
easier for me to just figure it out. Okay,
One more?
yeah, let's see how many we can get. Ready? Salute.
Ooh. Salute.
The product is 6.
Ooh.
Oh.
Okay. So she's got a 3 showing, and I know 3 plus 3 is 6. So mine must be a 2 because we doubled it.
That's right.
Perfect.
All
Woo.
right.
That's awesome. I think we've got enough to cover that round. Do you guys kind of understand how that would work? That would be definitely a lot of fun to do, and could get kind of involved if we got a little bit more like checking and tracking how many cards we did get.
Absolutely.
But we didn't come upon an ace or anything. If we had come upon an ace, our dealer could have said, well, maybe we'll do it by 11, and that might have been a little bit more difficult because I haven't done my 11s in a long time. But we really have enjoyed having you today. Let's go ahead and just do a quick recap of everything that we've had. So we worked on disappearing sequences. That was a lot of fun, and we kind of talked about that. Miss Gaudette worked on a fraction problem for us, really about estimating kind of where those would be on a number line. Miss Carnes was talking about interest, which I'm going to have to go and get some more jobs so I can start earning interest on my money. I'm really excited about that.
Maybe you guys could do some chores at home and earn some money.
Absolutely.
Maybe some interest.
And then we finished it all out by playing multiplication salute, which my husband and my son would be very proud of our little salutes because they're both military. My son's active duty and my husband is retired, but that was definitely something that was exciting. So we are so excited and hope that you guys had a really fun time with working with us today. And we want to thank you all for joining us with At Home at APS.
Thank you. Let's
have a good day.
Salute sign off.
Oh, yes. Sounds good.
Have a great day.